we go on to the next presentation by Zsolt, Bánki and Noémi Vadász. Noémi has been working at the Department of Digital Service Development of the National Archives of Hungary since the beginning of this year. She obtained her master degree in computational linguistics and her PhD too, and gained professional experience at the Hungarian Research Center for Linguistics. Zsolt has worked in various public collections since 1988 and has also worked as a project manager for several European Union and national projects. Since 2021, he has headed the Digital Service Development Department of the Hungarian National Archives, Directorate for Information Technology and Innovation. And they will talk about the use case of artificial intelligence in the National Archives of Hungary.
Thank you very much. Thank you. Happy to be here in this conference. Let me give you a little roadmap for our presentation. First, my colleague Zsolt is going to talk about some projects in the National Archives of Hungary, and then I'm going to talk about processing of civil registers.
So, dear colleagues, during the 2021, the National Archives of Hungary implemented a large-scale innovative volunteering program within the framework of the European Digital Treasure International Project, which aims to support the searchability of handwritten documents. The database is a digital research edition created in an innovative and unique way in the history of Hungarian public collections with the help of artificial intelligence. The work of the volunteers involved in the program has helped to make the handwritten data searchable and to organize into a database. The archives eventually processed the documents using a handwriting recognition algorithm created by Transcriptorium, a company funded by the Valencian University of Technology. Transcriptorium created the training set and model with Transcribus, and the correction process was carried out. The transcription tasks were completed by the volunteers in 6 weeks, with the original expectation of 50 pages to be repaired, but many exceeded this. The 70 volunteers who actively participated processed a total of 6,787 pages, 135,740 names, and corrected them, thus training the AI algorithm. This figure shows what the published data looks like. In the box next to the digitized image, you can see the names recognized by the model. This makes searching the database much easier. The next interesting project I would like to mention in the Hungarian prisoners in Soviet camps. On the basis of an agreement between the Hungarian National Archives and the Russian State Military Archives, on 8 April 2019, the Hungarian National Archives and the Russian State Military Archives have received the Hungarian Archives collection of the Hungarian prisoners of war of the Second World War. The digital copies of the so-called registration files of Hungarian nationalities, soldiers and civilians, captured, interned or arrested by the worker-present Red Army during and after the war. Second, and subsequently registered and prisoners of war in the Soviet Union were transferred to the Hungarian National Archives on 8 August 2019. The database, which is in Russian, and the digital collection are processed, and the persons on the files are identified using an algorithm developed by the Hungarian Research Center for Linguistics and the assistance of specialists. In addition to the Hungarian translation, the original Russian text is available on the data tables, and the index card can be consulted so that any user can look and translate them for themselves. The database search engine not only searches for the names of persons in first priority list, but also examines other variants of the names that the algorithm or the expert consider possible, since in many cases it is impossible to decide ambiguously which is the right version due to the difficulties described above. Hungarian Research Center for Linguistics return transliterated expressions with confidence values. For the project, we used Mirror 1.0, which I will talk more about soon. The procedure identifies different cards belonging to the same person. This procedure showed all occurrence of a person and the identity of persons in different records. Another of our projects, community processing of population exchange card files, focused on the processing of typewritten forms. During and after World War II, one of the historical traumas for individuals and communities was the permanent forced displacement from their place, residence, and homeland. The National Archives of Hungary has launched a community crowdsourcing program to process the population exchange cartons in its custody. The task is to train artificial intelligence annotation to read typewritten text based on the population exchange cartons. The aim of the task is to train the annotation software developed by MNL to recognize the typewriting. A key role is therefore played by correct, letter-by-letter transcription. The amount of data available for teaching was ample, even if we omitted text passages with uncertain reading or incorrectly marked segmented. Quantitative data was less important. The emphasis was on the quality of the annotated material. In this working environment, frame text boxes, segments, shows the typed text segments recognized by the software. If the selected area showed a mixture of print and typed elements, both they were annotated. The segmentation run by the software was about 75–80% successful. The text segments could be annotated and included the training material at this rate. The middle Relation Maker by AI application is a software developed by a partner of the National Archives, which is able to identify the merged entities from different sources using a hybrid, rule and model-based approach, and to enrich finding aids with namespace elements. The development of the application is project-driven, A new feature have been added to its versions. Version 1 identifies and rewrites names with one database. Version 2 can be used to enrich finding aids with namespace elements. And version 3 now has general validation function between arbitrary data sources. The aim of the National Archives of Hungary is to build a unified geographic namespace from the various public and private data sources available. One result of the exploitation of the geographic namespace is the automated enrichment of the growing number of online published databases with new namespace minds. While description of geographical namespace were created in the corresponding tables of each database at the time of data entry, they were only fragmentarily linked to the geographical namespace. The vast majority of the geographical namespace recorded were only recorded as strings in the system. It is on this basis that the other function of Mirel, in addition to entity merging, is built, which is to identify and link the geographical names of the finding aids to namespace elements. The starting point for the data enrichment is configuration file, in which the matching of namespaces and database string can be parameterized. The software makes up the three possible proposals with confidence value indicating the certainty in identification. Mirel provides a generic solution for the comparing different geographical data sources based on specific attributes. Mirel 2 is an application to establish the identity of the geographical names in the MNL geographic namespace, to create entity IDs and associate all the geographical names associated with each entity. The application has the ability to create its own model based on learned data, which can be relearned at any time. The application can dynamically choose between predefined parameters to build the best model, but can also be configured manually if necessary. The application is also able to perform entity merge between the MNL geographic namespace and its associated MNL geographic namespace and the finding aids. It associated the three highest namespace elements with a probably above the confidence value corresponding to the user preference with the geographical name in the finding aids. In model-based linking, we perform the linking using a machine learning model rather than rules. Depending on what data is available, for example, coordinate and multiple name variants, the reliability of the result returned by the model may vary. The georeference, the geographic location identified by the namespace are displayed in our public service using map data visualization. The map allows the researcher to easily navigate between the records associated with each site and gives a clear overview of the geographical distribution of the content of the finding aids. So, thank you. I would now like to invite my colleague Noémi Vadász to continue the presentation.
So let's move to the civil registers and processing them. In this picture you can see the variety and the diversity of this data, and then you can imagine how diverse the challenges we have faced in this project. There are the aims of the project. So we would like to publish the scanned images together with the data you can find on them as well. So we would like to process the content of the pictures. Thank you. In this phase, where are we now? So in the first phase of the project, we are processing only registers from one municipality, Abony. It means that Abony has about 40,000 registers, birth, marriage and death registers, in the time span from 1995 to 1890. And the workflow developed for Abony then will be extended to the whole Hungarian data in the same time span, which totals about 22 million pages. So we won't be bored in the years to come, I think. Here you can see the steps of our workflow processing these civil registers. First, after preparing the images for processing, obviously after scanning them, there is an image classification step when we sort the templates and the structure of these pictures. Then there is a segmentation of the text fields, and then handwriting recognition happens, and we load all the data into our database. Then we normalize and correct the text data corresponding to these data fields. Then we connect the geographical names to our namespace using Mirel2. After that, we link the persons together, the identical persons together in our database, and finally publish the whole thing. I'm not going to talk about each and every steps, only just a few ones. For example, image classification and templates. Classifying images is really challenging because there are many different layouts and formulas and tables in this data, and many of them are very similar. We use our software template builder to sketch out these layouts and these templates, and we use these layouts to connect the boxes directly to the database as well, so we label these boxes as well. And in addition, we have defined the distinguishing features of these templates, so we can sort these pictures with different layouts in a step. These pictures show what a birth register looks like after we have outlined the useful areas of the data, and the field names are assigned to them. So the green boxes are the useful areas, and it is written in white. You cannot see, but it is written in white that to which field it belongs in the database. Then the next step is handwritten text recognition. Our solution for this task was to train the TR-OCR model. We have several training data. We have typed a lot. We have as well training data for typewritten material as well, but now I only listed the handwritten ones, what we used. Currently, our best result in the handwritten data are 6% character error rate and 15 to 18% of word error rate, which is fair enough, but our models are still under development, so we wait them to be better. This is our annotation tool that we use for creating our training and evaluating data. And we can use this tool as well, not only for annotating them and curating the data, but to also to examine the output of the data as well. As you may see about the segment about Szalók, which is in an orange here, it has been typed by 3 annotators, and below it we can see the hypothesis of the model together with their corresponding confidence value, and highlighted in green the correct solution which matches with the manual solution. To store the data, an SQL database is used. The data are loaded into it by the fields of the templates, and therefore the database contains all the metadata, the output of the HTR, the corrected and normalized data, and all further results based on them. And as I mentioned, the corrected and normalized data is in the database as well, because we needed to post-process to work on this output of the HTR, obviously. It supports 2 important functions. Firstly, it helps to make the data searchable, and secondly, it is essential for linking the persons in the database, because we need correct names, correct data as well. There are different tasks in this step. We have only worked on the overloaded fields, the correction and extraction as well. Now we work only with the hypothesis with the highest confidence, but later we are planning to handle all the hypotheses as well, because sometimes the correct solution is between the hypotheses but with lower confidence, as we saw. So managing overloaded fields, as you can see in this picture, it is a part of a birth record, and you can see that in the box there are 3 different data as well, because there is the given name of the born child, the gender and the religion, so we need to split this data to make it ready to load to the corresponding field of the database. We do this now by rule-based methods. Some correction, normalization, standardization, and some extracting things, but I think that I don't have any time for these steps. Here you can see the result of the post-processing steps for now. For some complex data, we needed to do some further segmentation. For example, if you think to addresses, we had to split municipalities and addresses, or for the names, we would like to split them to family name, given name, and other parts of the names to be much more digestible. For this task, I have trained a Hubert model, which is a Hungarian birth model, for segmenting the names. It was trained with label data, and the labels were, for example, family name, given name, maiden name, or widow, or something like this that can appear in a name. And the performance was evaluated on 1,000 names. They were manually segmented as well, and the F measure was 83%. The last step is to connect the identical persons in the database, because next to making the data searchable, it was our second important aim in this project. A few thousand pairs of persons were annotated manually according to whether they are the same person or not. And based on this training data and some other predefined rules and features, the model is now able to tell if 2 persons are identical or not in the data. The quality of the model is still being evaluated, so I cannot provide any numbers here now. But later, more distant family relationships can be calculated based on them, because there are a lot of relationships are inherently in the documents, for example, mother and child, or other family relations. So thank you very much. It was our presentation. I hope you found interesting what we are doing in the archives.